Hi, today I'm going to be solving 20 questions on radicals and exponents. So let's get started. The first question is square root of 32x squared. The first thing that I like to do with these types of questions is to represent anything under the radical in terms of exponents. And I noticed that 32 is equivalent to saying 2 to the power of 5 times x squared. Now, I can represent the radical. Square root is the same thing as saying something to the power of 1/2. So I'm just going to rewrite that. And when you have exponent on top of exponent, you can multiply the exponents. So you have this times x because the 2's cancel. And so I have 2 to the power of 2 times 2 to the power of 1/2 times x, right? And the reason for that is because 5 over 2 is equal to 2.5. And I can write this, I can break this down into 2 to the power of 2 times 2 to the power of half. And so I get 4 times, and 2 to the power of 1/2 is simply square root of 2. And then x is just comes up front. So the answer is 4x times the square root of 2. B. Again, I'm going to do the same thing. A cubed times square root of a cubed. So a cubed times a to the power of 3 and then to the power of 2. Right? So I have a to the power of 3 times a to the power of 3 over 2. And using the exponent rule, I can add the exponents together. So this is like saying a to the power of 4.5, right? Because 3 over 2 is equal to 1.5. And this is the same as a to the power of 4 times a to the power of half, which is a to the power of 4 times square root of a. So the answer is A. Moving on to question number 3. So this one involves fractions. Square root of g over 4 times the square root of 4g. So I'm going to do the exact same thing, g to the power of 1/2 over 4 times square root of, well, 4 is equal to 2 to the power of 2, and then square root of g is just g, right? Square root of g. And I'm going to rewrite the bottom again in terms of exponents like that. I'm going to expand the brackets. So 2 to the power of 2 and half, and those cancel, so I just have 2. And g to the half, it stays. And I can cancel these out, so I have 1 over 8. That's not one of the answers. Oh, I think there's a typo here. So this is supposed to say, the 4 I think is not on the denominator, but rather it's 4 times square root of g over square root of 4g. I think that's what they meant to say. So in that case, I can revise the question and say everything is same up to this step, except for 4 should move up here. So you have 4 over 2, which is 2. So the answer is A. Okay, moving to question number 4. Okay, so this time it's cube root. So let me just rewrite that as power of 1/3, because cube root is equivalent to saying something to the power of 1/3. And then denominator is square root. So 27y to the power of 2 to 1/2, right? And I know that 27 is equivalent to 3 to the power of 3 times y to the power of 3 and 1/3. And 23, I'm just going to do the same thing, 3 to the power of 3, y squared, and 1/2. And if I do that, 3 to the power of 3 to the power of 1/3 is just 3. Y to the power of 3 to the power of 1/3 is just multiply the 2, so y. In the bottom, it's 3 to the power of 3 over 2, and y to the power of 1, or y. And the y's I can cancel. And this is like saying Okay, so that's like saying 3 to the power of 1. So I can do 1 over 3 to the power of 1/2. Or 1 over 3 to the power 1 over square root of 3. Right? And another way to write this is if you rationalize this, that means if you want to get rid of the radicals in the denominator, we usually like to do that. We multiply by square root of 3 over square root of 3. So on the top, we have square root of 3. On the bottom, square root of 3 times square root of 3 is 3. So square root of 3 over 3. So these two are equivalent expressions. So the answer is A. Question number 5. Let me rewrite this also. So a squared times b to the power of 1/2 times ab squared to the power of 1/2 divided by ab to the power of 1/2. Okay, so let's just expand the brackets. So a squared, so 2 times 1/2 is 1, b to the power of 1/2 times a to the power of 1/2 times b over a to the power of 1/2 and b to the power of 1/2. Notice the b to the 1/2, they cancel, and a to the power of 1/2, they cancel. So the answer is a times b, C. Question number 6. This time, what do we have here? So we have square root of m cubed over n to the power of 5, and all of that to the power of -2. So what I'm going to do is I'm going to rewrite it as we normally do. So this times power of 1/2, and then on top of that we have another -2. And before I start multiplying, I can simply get rid of these. So it's m to the power of 3 over n to the power of 5 to the power of -1. And if it's -1, I can switch the top and the bottom, switch the denominator and the numerator. So it's n to the power of 5 over m to the power of 3. And the answer is B. Question number 7. ab cubed over b to the power of 4. So let's do the expansion. So a to the power of 3, b to the power of 3 over b all to the power of 4. So that's a to the power of 12, b to the power of 12 over b to the power of 4. And b to the power of 12 and b to the power of 4, you do 12 minus 8. So it's 12 minus 4. So the answer is a to the power of 12 times b to the power of 8. The answer is D. Okay, moving on to question number 8. Okay, so 4g squared to the power of 3 times g to the power of 4, all to the power of 1/2. Again, I'm going to expand the brackets. So 4 to the power of 3 times g to the power of 2 times 3 is 6 times g to the power of 4, and all to the power of 1/2. And that's going to be 4 to the power of 3 over 2 times, well, g to the power of 6 times g to the power of 4 is g to the power of 10. To the power of 1/2 is g to the power of 5. Okay. And so, did I miss something? No. And 4 to the power of 3 over 2 is the same as 2 to the power of 2 to the power of 3 over 2. And these cancel. Whoops. So 2 to the power of 3 is 8. So 8 times g to the power of 5. The answer is C. Question number 9. Square root of 9pr divided by pr all to the power of -3 over 2. So first thing is I'm going to do 9 is the same as 3 to the power of 2, pr, and this all to the power of 1/2. And if I want to do this, it's pr to the power of -3 over 2. What I can do is, sure, I'll just leave it as pr to the power of -3 over 2. And if I want to get rid of the negative sign, I can just invert and multiply, which means the pr is going to come up to the numerator like this. And Notice that the negative sign is gone in for, on the exponent for PR this term. Right? And I'm going to do the same thing. 3 to the power of 2 to the power of 1/2. It's just 3. And p to the power of 1/2. R to the power of 1/2. P to the power of 3 over 2. R to the power of 3 over 2. And so that's going to be 3. And p to the power of 1 over 2 times p to the power of 3 over 2 is p squared. And same thing for r. R to the power of 1/2 times r to the power of 3 over 2 is r squared. So the answer is E. Question number 10. X over y squared times y over x to the power of -2. I'm going to flip so x over y and make that the positive exponent, and then x over y. Right? And this is the same as x over y to the power of 4, isn't it? Right? And now I'm going to expand the brackets. So x to the power of 4 over y to the power of 4. Sorry. And then over xy. And this is like saying xy over 1. And you can multiply the outside, and that goes on top. And you multiply the inside, and that goes on the bottom. So x to the power of 4 times 1 is x to the power of 4, and that goes on the numerator. And y to the power of 4 times xy is x times y to the power of 5, and that goes on the denominator. I can cancel one x, so that becomes 3. So the answer is x cubed over y to the power of 5, or the answer is B. Moving on to question number 11. A to the power of 2 over 3 is equal to 6, and they're asking what is a to the power of 4 over 3? Well, this is the same thing as saying a to the power of 2 over 3 times to the power of 2, because when I multiply the exponents, I get a to the power of 4 over 3, right? And we know what this is. It's a 6. So 6 squared is 36. E. Number 12, square root of p to the power of 4. Well, that's just p to the power of 1/2 to the power of 4 is equal to q to the power of -2. And the 2 and the 4, they can be reduced. P squared is equal to q to the power of -2. And this is like saying 1 over q to the power of 2, right? And we know what q is. Q is 1 over -1 over 3 to the power of 2, right? Which is 1 over 1 over 9. Right, the negative sign disappears. And 1 on the top is like saying 1 over 1. So I can multiply the outside and put it on top, which is 9. I can multiply the inside and put it on the bottom. 9 over 1 is 9. So p squared is equal to 9. So p can be either plus or -3. The answer is D. Moving on to question number 13. What is the value of a times square root of b to the power of -ab if a is 1 over 3rd and b is 9? So let's just plug it in, because I think some of this can be reduced. And so all I'm doing is plugging in the values of a and b. Well, let's do so what's square root of 9? That's just 3, right? And -1/3 times 9 is -3. But we know that 3 and 1/3 get canceled, so that's 1. So 1 to the power of -3, or actually 1 to the power of anything is going to be 1. Answer is C. That was easy. Question number 14. What is the value of xy to the power of y to the power of x if x is equal to 2 and y is equal to -x? Well, first of all, if y is equal to -x, then that's just -2, right? So let's plug it in. 2 times -2 to the power of -2, all to the power of x, so 2. What's 2 times -2? -4 to the power of -2 to the power of 2. So that's like saying -4 to the power of -4. If you have a negative, then you can flip. So it's going to be 1 over -4 all to the power of 4, right? and this is like 1 to the power of 4 and negative 4 to the power of 4. 1 to the power of 4 is 1. And negative 4 to the power of 4 is 16 times 16, so 256. So the answer is